Four forces act at a point there, and they are in polar form at the moment, and we need to determine the resultant, which is a combination of all four of them in both polar and Cartesian forms in the range theta between 0 and 360 degrees. So let's convert the four forces to Cartesian form, and our forces are A is 7, magnitude of 7 with an angle of 320 degrees. And that's our formula there for converting from polar to Cartesian. So our angle is 320 there for force A. We'll stick that in instead of theta into the formula. Our magnitude is 7, that goes in instead of R. And we'll just work those guys out. And we'll get so many I and so many J. So we have 5.36 I plus, minus 4.5 J. So that's it there. That's force A now in Cartesian form, like coordinates on a map, like X and Y coordinates, for example. So we'll adopt the same procedure now with force B. Theta and force B there in the formula is going to be 190, and R is 5. Plug in the values, and using the Casio we get minus 4.92 I minus 0.87 J. We'll do the same procedure with force C. R is 7, our theta is 65. We get 2.96 I plus 6.34 J. That's it in Cartesian form. For force D, R is 6, the magnitude is 6, and our angle is 130. Theta is 130. So plugging those values into the calculator, we get minus 3.86 I plus 4.6 J. Now, to get our answer of our resultant in Cartesian form, we can just add up the forces when they're in Cartesian form. So we'll add up all our I components and add up all our J components. So we'll add 5.36 minus 0.42, 2.96 minus 3.86, and we'll get an answer for the I part of our resultant. And do a similar process for the J part. So that's our answer. The resultant is minus 0.46 I plus 5.57 J. Now we want that. We have it now in Cartesian form, and we want it in polar form. So next up we have to convert our resultant to polar form. So we sketch here, we're going minus 0.46 on the I-axis, and then we're going up 5.57 on our J-axis. So we'll use Pythagoras' theorem there, the little formula back at the exam sheet, to figure out the magnitude of R. And we get 5.59 approximately for R. Next, what we need is the angle. We'll want the angle in relation to the positive sense of the x-axis eventually, but first let's get that angle alpha marked in the triangle. Tan alpha equals the two sides divided like so. Get the inverse of that, and we will get an angle for alpha of 85.28 degrees. Now be careful, that's not our final answer. Theta there marked in red is the angle we're looking for, so subtract alpha from 180, and we get 94.72 degrees. So our resultant then in polar form will have a magnitude of 5.59 and the angle 94.72.